Welcome back to Applied Algebra. We are moving on to Chapter 7, and our first section has to do with ratios. So a ratio is simply a comparison of numbers. They're used a lot with scaling, which is used in when you make a prototype or something small before you actually get to make the actual item. They're also used with maps. Even though that we don't use paper maps anymore, the programs that like MapQuest, they actually use the idea of scaling. It's programmed into it. So let's quickly write down our definition. It's when we compare two numbers. Now that comparison can be written using the word to. It can be used with a colon. It can be used as a fraction. Those are the three main ways that we'll see it. If we need to reduce our ratios, we simply have to ask ourselves what goes into both 4 and 16 in example A. They're both divisible by 4, so I will divide them both by 4. So my simplified ratio becomes 1 to 4. So the idea is for every unit on my scaled down version, the picture, or even my prototype, the one that's actually going to be drawn is 4 times larger. If I do the same thing with the next one, they're both divisible by 7. Oh, and I just realized I changed how I wrote this. We'd want to try not to change how we write them. If they're given with the word to, let's go ahead and leave it with the word to. Whereas on B here, I'm dividing by 7, so when I go ahead and change it, it's going to be 1 to 2. So I say the word 2, but I'm not showing it. So the other one is twice as big. On the next one, they're both divisible by 5, so I'm going to divide them by 5. And so it's 1 over 5. So the larger one is 5 times as big. Notice in A, B, and C I didn't have any units. Units really aren't needed unless they're different units. So even on D where it says inches and inches, I don't really need those because I know that whatever I'm working with should be in that unit. So I can just go ahead and divide by 6. Excuse me. So 6 divided by 6 is 1. 18 divided by 6 is 3. And I don't need the units because they're the same. So it's a 1 to 3. On the next one, they do have the units. So I have feet and inches. If I want to keep them that way, I'm going to go ahead and divide by 3. I'm going to end up where I have to put down 1 foot is 5 inches. So every 5 inches on the smaller one is a foot on the bigger one. Now if I don't want to write the units in, what I can do is I could convert. So let's see what that would look like. If we do, let's go to inches. So every 3 times 12, 3 times 12 is 36. So every 36 inches to 15 inches. Again, I can divide by 3. So what I get is it's a 12 to 5 ratio. So every 12 units on the larger one is equal to 5 units on the smaller one, whether that's in feet or inches. So I don't need the units if I do the same units, but if I have different units, I do have to write them down. So you can do your answer like this or like this. And I actually just realized I could have just used the reduced one because 1 foot is 12 inches. Okay, so I have inches squared and feet squared. Neither one of them are divisible by anything, so this would be considered a reduced unit. Now if I went ahead and switched, there are 144 square inches in a square foot. So I'm going to multiply 3 times 144. 12, 13. So it's 432. So it's a 10 square inches to 432 square inches. They're only divisible by 2, so we'll go ahead and divide them by 2. So I end up with a 5 to 216, and those are both in square inches. Or I could leave it as the 10 square inches to 3 square feet. Okay, when we're doing ratios with fractions, we just have to simply think about what do we know about fractions. When we're doing ratios, the reason we do a division sign sometimes is because it's like a division problem. So we're going to go 4/5 divided by 8/7. Instead of dividing fractions, we multiply them by their reciprocal. I'm going to reduce beforehand. 4 goes into 4 once and into 8 twice. We multiply straight across. 1 times 7 is 7. 5 times 2 is 10. So my ratio for this one is a 7 to 10. So every 7 units on the smaller one is 10 units on the bigger one. So we're going to get our fractions, if possible, to non-fractions. The next one has a mixed number. So we're going to go ahead and take it out of that mixed number. So again, I'm asking you to know some previous information. 4 times 2 is 8. 8 plus 3 is 11. So that's 11/4 being divided by the number 4. Whole numbers get put over 1 before we do any flipping and multiplying. So it becomes 1/4. Multiply straight across. It's 11/16. So my ratio is 11 to 16. So every 11 units on the smaller one is 16 units on the larger one. We'll do that same idea on I. It just has 2 of them. So 5 times 6 is 30. 30 plus 2 is 32. We're dividing that by 4 times 3 is 12. 12 plus 3 is 15. We have to flip the second one. And nothing's going to reduce, so we're just going to have some large numbers. 4 times 32 is 128. 5 times 15 is 75. So it's 128 to 75. Now they don't always seem reduced, but they are. So this last one is in a fraction form. Again, it has units. Now this one you'll notice there is no way that we can change gallons into miles or miles into gallons. And this one is, if you think about when your fuel, if you're driving, they're going 350 miles on 7 gallons. So these won't always get rid of our units. 7 goes into 350 50 times. So what they're telling us is we can go 50 miles per gallon. And you can write it like this, or you can leave the actual units more written out. You have some options on which ones make more sense to you. So let's look at what some scenarios look like. The ratio of the voltage drops across 2 resistors wired in series equals the ratio of their resistances. So it just makes these two have to be in a ratio. So it's 820 to 500. And when they're written in a situation, you get to choose how you write your ratio. You can do a fraction, you can do a colon, you could use the word 2. Again, I do want to reduce them. They're both divisible by 10, so I'm going to do that first, get them down a little bit smaller. So I end up with 82 to 50. I see they're both even, so I'm going to divide them by 2. I end up with 41 to 25. 25 is only divisible by 5, which does not go into 41. So it's a 41 to 25. They're both in the units of ohms, and resistances are always in ohms, so I don't need to worry about that one. Find the flow rate for the given IV. Assume a drop factor of 15 drops per milliliter. So we're going to take 1,200 milliliters in 6 hours. So I go ahead and write that as a ratio. I find this easier to do in a fraction because I'm actually going to do what's called dimensional analysis to change the units. So 1,200 milliliters in 6 hours, I make that into a fraction. I have to bring in here the idea of this 15 drops per milliliter. So if I want milliliter, I need this milliliters to be opposite. So I need the milliliters to be opposite, so I'm going to do 15 drops, put the drops on the top, per milliliter. So that's how I know where to put what. I need opposite units to be one up and one down. So what I have now is it tells me how many drops I need per hour, and that's really hard in the medical field to work with that. Instead, they tend to work with drops per minute. So we're going to switch from hours to minutes. So think about what you know. I know there are 60 minutes in 1 hour. So since I need the units that are the same to be on opposite ends, I'm going to put the hour on top and the minutes on bottom. That way I have one on top and one on bottom. So I have drops per minute, which is what we want to be in. So now I'm going to go ahead and multiply. 1200 times 15 is 18,000. 6 times 60 is 360. Divide those. 18,000 divided by 360 ends up with 50. So they'll set the machine to go 50 drops per minute. Okay, our last one. Find the length of time that IV should be administered. Assume a drop factor of 10 drops per milliliter, 1,500 milliliters at a rate of 50 drops per minute. So this is saying how long is it going to take them to get through the bag. So we have 1,000 milliliters. And they're going at a rate of 50 drops per minute. Okay, so I'm not actually going to move to the 50 drops yet because I only have milliliters. So I'm going to work with the stuff that I know about milliliters. I know that there are 10 drops per milliliter. So let's put that one in first. I need the milliliter on the bottom, which puts the 10 drops on the top. That way my milliliters cancel. Now that I have drops, it makes more sense to go 50 drops now. And if I need the drops to be on opposites, I need to put the 50 drops on the bottom. That's per minute. My drops cancel, and so I'm really just left with time, which is what I was looking for. What's the length of time? So 1,000 times 10 times 1 is 10,000. 1 times 1 times 50. 10,000 times 50 is 200, so it's 200 minutes. Now if you think about it, would you want to have to figure out what 200 minutes is? So it makes more sense for us to go into hours. So let's divide that by 60 so we know about how many hours that is. So my calculator says it's 3 1/3, which means it's going to take 3 hours and 20 minutes for that bag to be given to the patient. Okay, work through your ratio assignment. If you have any questions, let me know, and I'll be back with